Hello, Honors Algebra 2. I hope you enjoyed your Unit 0 test part 2, and now you get to watch a fun video about factoring. So this video is going to cover a bunch of factoring that you've seen before, as well as just a little bit of new information that is related to what you already know. So let's go ahead and get started. We're going to begin with greatest common factor. These problems are noticeable because they generally have more than one variable, and usually they have a number that is the greatest common factor. So here you have 4x squared y cubed plus 8x to the fourth y squared plus 12x to the fifth y to the fourth. The first thing to do to factor this type of problem is to find the number that is the greatest common factor, which may or may not be one of the coefficients that's already there. So for here, it would be a 4. 4 goes into 4, 8, and 12 evenly. Okay, so now we're going to look at the variables. You have an x squared, you have an x to the fourth, and you have an x to the fifth. You want to use the one that goes into each of those. Now remember, with an x squared goes into an x to the fifth. So it's not like with 2 and 5. 2 doesn't go into 5 evenly. So our GCF here is x squared. And then you have a y cubed, a y squared, and a y to the fourth. We take the biggest one that they all have, which would be y squared. They all have a y squared within those. Okay. So now what I like to do is remember that inside your parentheses, the number of terms in your parentheses match the number of terms in the total problem. So since there are 3 total terms, I'm going to put 3 blanks with some plus signs. And then basically you're doing reverse distributive property. You have 4 times what is 4? Well, just a 1. X squared times what is x squared? Well, you already took care of that. Y squared times y is y cubed. Now we have 4 times 2 is 8. X squared times x squared is x to the fourth. And your y squared, you already have enough of those. And finally, you have 4 times 3 is 12. X squared times x cubed is x to the fifth. And y squared times y squared is y to the fourth. And this is your final answer. All right, let's try another one. Notice you have 4 terms this time. That means you'll have 4 terms in your parentheses. We look for the number GCF first. You have 6, you have 15, 9, and 3. You can pull out a negative if you'd like. I usually just pull out the positive. It doesn't really matter. I'm going to take out the 3. And they all have an x, which means x is a part of our GCF. And we take the biggest one that they all have, which would be x squared. And then we look to see if they all have y's, which they do. Now, if one of them didn't have a y, then y would not be a part of our GCF. But they all do have a y, so y is our GCF. Okay, and now I'll fill in the blanks. 3 times 2 is 6. I need 1 more x. I do not need any more y's. Okay, notice that if you used y squared here, that would be a problem because you have less than that. So that's why you're taking the smaller variable, which again is the biggest one that they all have. All right, so that's for that one. 3 times 5 is 15. X squared times x squared is x to the fourth. And y times y is y squared. 3 times negative 3 is negative 9. We need an x to the third, and we need a y to the fifth. And then the last one, you're going to notice that your GCF is the same as the last term. This is one of the reasons I like to use the blanks, because a lot of times if you don't do that, you forget your last term here. Here your last term is just a 1. Remember that when you're distributing, you need to get back to this 4 terms. So you do need to have this 1 here. It's kind of like a placeholder so that when you multiply, you do get the 3x squared y. All right, so that is greatest common factor factoring. Now we're going to do reverse FOIL, which is basically your regular type of factoring you normally do. Reverse FOIL works for polynomials in the form x squared plus bx plus c. When factoring, you're going to find two numbers that multiply to the end and add to the middle. And you may have to pull out a GCF first. And that GCF can be a number or a variable. It's just entirely dependent on the problem. All right, so here is your first example. And actually, I believe in your notes, this is a negative 22. So we're going to change that to a negative 22. So we have x squared minus 22x plus 120. We are going to multiply to 120, and we are going to add to negative 22. Basically, you are doing reverse FOIL, which is why this section is called reverse FOIL. So you're going back to the original multiplication problem. The numbers that multiply to 120 and add to negative 22 are a negative 12 and a negative 10. The order that you put these in your parentheses does not matter, but it does need to be in this form. This is factored form. All right, let's try this one. This would be multiplying to negative 16 and adding to negative 10. And if you do negative 8 and 2, that multiplies to negative 16, but it doesn't add to negative 10. So if you do negative 8 and negative 2, that gives you negative 10, but that would give you a positive 16. This is what we call prime. You can also write it as unfactorable. This is not the same thing as no solution. Okay, so please don't put no solution. It's either prime or unfactorable, one of the two. All right, next, if you have a number in front of your x squared, ideally that number comes out evenly and is a GCF. Now this isn't always the case. We'll look at that more tomorrow, but here the 3 does come out evenly. So we're going to take out that GCF like this. And then you're going to do your multiply add just like before. You're multiplying to 21, you're adding to 10. And those numbers would be positive 7 and positive 3. Please keep the 3 in front, and this would be your final answer. All right, next is number 6. This one looks a little different because they each have an extra x. This is an example where x is your GCF. So we're going to take that x out. X squared plus 2x minus 15. And now the x stays out front, and we're going to multiply to negative 15. And we are going to add to 2. And those numbers are a positive 5 and a negative 3. Please watch your signs. If you make the 3 a positive and the 5 a negative, you would be adding to a negative 2 here. Okay. All right, no number in front of x squared. We'll go straight to multiplying to 16 and adding to 8. And those numbers would be positive 4 and positive 4. Since these are the same, we can also write this as x plus 4 quantity squared. This is something we'll get more into tomorrow. All right, so these last 3 on this page are a little different, and that's because you have an x to the 4th here. Now, I want you to notice there isn't a GCF. They don't all have an x. So this is still reverse FOIL. It's just going to be a little different than what you're used to. Normally, when you do FOIL, you do the first times the first, and that gives you x squared. But here, we need it to multiply to give you x to the 4th. So all you're going to change is that your first terms in each of your parentheses are going to be x squared. But everything else stays the same. You're still multiplying to negative 40, and you're still adding to 3. And those numbers would be a positive 8 and a negative 5. And if you look, if you FOIL this out, you'll get minus 5x squared plus 8x squared, and you'll get that positive 3x squared, while still getting the negative 40. All right, let's try it again. So again, this type of factoring will occur when you have the x to the fourth and the x squared and then just a number at the end. We need an x squared and an x squared so that if we were to FOIL it back out, we would get x to the fourth. You are multiplying to 25, adding to negative 10. So it would be a minus 5 and another minus 5. So this could be written as x squared minus 5, quantity squared. Okay, one more like this. Again, you need an x squared and an x squared. You're multiplying to negative 42 and you're adding to negative 1. So that would be negative 7 and positive 6. All right, let's flip the page. Next is difference of squares. This is one that most people are fine with, but we're now going to combine it and make it a little more difficult. Difference of squares says that if you have anything in the form of a squared minus b squared, it can be written as a plus b times the quantity of a minus b. So for example, in x squared minus 9, your a value is x, your b value is a 3, and this becomes x plus 3, x minus 3. The reason that you don't have a middle term here is because when you multiply, you'll get plus 3x minus 3x, or minus 3x plus 3x, and those middle terms will cancel. Okay, so in this one, your a term would be what the square root of 81x squared is, which is 9x, and your b term would be 10. So you have 9x plus 10, 9x minus 10. Okay. All right, let's combine this with one of the types of problems we did before. Notice that initially this is not difference of squares. You have your x to the fourth and x squared. So this will be our reverse FOIL, multiplying to negative 90 and adding to 1, which is a positive 10 and a negative 9. However, what you should now notice is that this x squared minus 9 is still a difference of squares. We did this above in number 11. So you do need to continue factoring, and your final answer would look like this. Now, the order of these parentheses doesn't really matter. I mean, ideally, the x plus 3 and x minus 3 are together, but if you have the x minus 3 before the x plus 3, that's fine. All right, another difference of squares, or is it? One thing to note is if you have an a squared plus b squared, this is always prime. Always, always, always. There's no way to get those middle terms to cancel if they are both a positive or both a negative. So this is prime. All right, number 15. This is a difference of squares because x to the 8th can be broken down in pairs. So this, your a value would be x to the 4th, and your b value would be a 1. So x to the 4th plus 1, x to the 4th minus 1. But now this is still difference of squares. This becomes x squared plus 1, x squared minus 1. But now this is still difference of squares. So yes, you do need to do all of this. X plus 1, x minus 1. And this is our final factored form. All right, last difference of squares problem, and it has fractions, so I know you're excited. Basically, as long as you have perfect squares and you have a minus sign, you can do difference of squares no matter how crazy it looks. You have a plus, you have a minus. Here, your a value would be x over 4, and your b value would be, you have 3y over Square root of 169 is 13. And that's it. So now if you were to FOIL this back out, you would get x squared over 16, and your middle terms would cancel. And when you multiply the 3y over 13 times the negative 3y over 13, you would get 9y squared over 169 with a negative. All right, last thing today are a couple of multivariable problems. So again, these are really the same thing. You might be doing reverse FOIL, you might be doing difference of squares, but ultimately they're the exact same thing. It's just you have more than one letter. Again, if you can pull out a GCF, you always want to do so. So here a 2 will come out. None of the variables will come out because they don't all have an x, they don't all have a y. And now this is still reverse FOIL because you have an x squared here. You're multiplying to negative 20y squared and you're adding to a 1xy. So don't worry too much about the letters right now. Just worry about your first term. This times this needs to be x squared. So I'm going to put an x and an x. I'm multiplying to negative 20 and adding to 1. That's a positive 5 and a negative 4. But when I multiply these, I need to get a y squared, which means each of these need to have a y. And now you can just check. Okay, x squared, it'd be negative 4xy, positive 5xy, gives me 1xy. Yep, that's what I want. 5y times negative 4y is negative 20y squared. And there you go. Last one. All right, no GCF, they don't all have an x or y. No number that comes out of all of those. So again, we're going to do some reverse FOIL. Multiplies to 8, adds to negative 6. The first term times the first term gives me x to the fourth, so I need to have x squareds. The numbers that multiply to 8 and add to negative 6 are a negative 4 and a negative 2. But notice, when those get multiplied, you need to get an 8 y to the fourth. Right now I just have an 8. So to get y to the fourth, those both need to have y squareds. Now, a lot of people would say, oh, that was awful, I'm glad we're done. But technically you're not done yet. Take a look at this. That is still difference of squares. You have two terms that are squared, you have a minus sign. So that becomes x plus 2y and x minus 2y. And then you bring down the x squared minus 2y squared. Now, this is not difference of squares because you can't take the square root of 2. So if that were like a 16 or a 4 or a 9, something like that, then you could break this down further. But since it's a 2, you cannot. And now this problem is completed. All right, we'll get excited because we're going to spend the next few days factoring, and then we're going to do even more in our next unit. So factoring is not going away. It was important in Algebra 1, it was important last year, and it is still important. So if you're having trouble with these skills, make sure you stop in and see me or visit the resource room would be way better, wouldn't it? Resource room, and have a great day. Bye-bye.